All right, let's try this second example problem. We think that it's a quotient rule problem. So it's this one right here. G of x equals e to the x times x to the third. We'll take a screenshot of the problem, copy it, and we'll put it on an extra page here. Right. There's the problem that we'd like to solve. So here we can think of g of x as the product of two functions. Let's say f of x times h of x, where f of x is equal to e to the x and h of x is equal to x to the third. And so by the product rule, we have that g prime of x is going to be the first, so that'll be f of x times the derivative of the second, h prime of x, plus the second, h of x, times the derivative of the first, f prime of x. So there's the product rule at play. So let's just think about this. F of x is e to the x, so it would be e to the x. H prime of x, let's write that down. What's h prime of x is going to be 3x squared. And f prime of x is going to be e to the x. So h prime of x is 3x squared. Plus, let's see, h of x, which is x to the third, times f prime of x, which is e to the x. So what do we get? Let's write it this way. How about 3x squared e to the x plus x to the third e to the x? It'd be a perfectly good way to write the derivative. Or you could factor it if you'd like. I can see that an x squared and an e to the x are commentable terms. So we end up with what? 3 plus x in parentheses. So another way to write it would be that way. And let's do our Desmos check again, see if it actually works. So I'll go to Desmos this time. Oops. And get rid of this function that I had in there. And I guess we should call it g since it's g that we used. Oh, doesn't like me. Oh well. Okay, so g to the x, or g of x is e to the x. So let's see, e raised to the x. Oops. E to the x times x to the third. All right, so the red function is our graph of the function, and the blue is the derivative of our function. It's a pretty neat looking function. And the question is do we have that derivative in hand? We think we do, right? We think that this thing, we'll call it h of x, just to give it a different function name. We think that it looks like what? Let's see, x squared times e to the x and right away it looks like we're kind of on the right track. You can see the purple function starting to fill in, and then what we said, 3 plus x, or x plus 3, and indeed there it is. If I turn the purple function on and off, I can see that it does overlay Desmos's mechanical derivative there in blue. So indeed, we must have found the right derivative. All right, I'll stop the video here and I'll do the third example problem in the next video.